Hello, everybody. Today we're going to get into module 10, which is vibration. So hopefully we'll have some good vibrations here. There we go. Chapter 10. Yeah. There we go. There it goes. Objectives. Identify different sources of vibration as well as the risks of permanent damage to the body if exposed to high levels of vibration. Identify signs and symptoms involved in exposure to vibration and learn how to reduce vibration exposure. Topic of vibration and occupational exposure to vibration is complex. There you go. And this chapter provides a simplified overview of the topic. There's a lot about vibration, a lot of math in it. Everybody experiences some level of vibration almost constantly. The Earth vibrates at approximately 7.83 hertz. Sound waves are vibrations that we perceive in a relatively narrow frequency range, approximately 20 hertz to 20,000 hertz. Vibrating equipment also generates sound waves, though for this chapter, occupational sound isn't the focus. We'll talk about sound later on. Occupational exposure to vibration can result from a wide range of equipment, including grinders, drills, generators, motor vehicles, compressors, fans, and even flowing fluids and air even. What's a hertz? Well, hertz is equivalent to cycles per second. In other words, 1 divided by a second. It's the duration of that many periods of the radiation, all that stuff of the atom. And I am not going to get into that. And that's not going to be on any test either. The vibration is the oscillating, reciprocating, or other periodic motion of a rigid or elastic medium or medium force from a position or state of equilibrium. Frequency is measured in hertz. It is the number of to and fro movements made in each second. 100 hertz equal 100 complete cycles in a second. There's a lot goes on in vibration, believe it. Amplitude is the magnitude of vibration. A vibrating object moves to a certain distance on either side of its stationary position. Amplitude is the distance from the stationary position to the extreme position on either side and is measured in meters. The intensity of vibration depends on the amplitude. Acceleration is measured how quickly speed changes with time. Expressed in units of measure, meters or feet per second, or per second squared. The magnitude of acceleration changes from 0 to a maximum during each cycle. It increases as the vibrating object moves further from its normal stationary position. Speed or velocity, v, varies from 0 to a maximum during each cycle of vibration. It moves fastest as it passes through its natural stationary position to extreme position, then slows as it approaches the extreme, where it stops and then moves in the opposite direction. Expressed in units of measure per second, meters per second, or feet per second. Wavelength is the measure of peak to peak of one vibration cycle. Resonance. Every object tends to vibrate at one particular frequency called the natural frequency. The measure of natural frequency depends on the composition of the object, its size, structure, weight, and shape. If we apply a vibrating force on the object with its frequency equal to the natural frequency, it is a resonance condition. A vibrating machine transfers the maximum amount of energy to the object when the machine vibrates at the object's resonant frequency. The human body has natural resonance frequencies ranging from about 2 hertz to about 100 hertz. That is from the Canadian Center for Occupational Health and Safety. That's a snapshot of vibration. So your cycle is from the time it goes from the crosses the timeline here, goes all the way up to the top and the bottom. That's the amplitude, and the cycle is one complete movement from the top to the bottom and back again. Now, these are also from the Canadian thing on vibration, which we talked about frequency and amplitude already. Acceleration, the speed of a vibrating object varies from 0 to a maximum during each cycle. This is talking about the speed along that curve. And that's just a repeat of what we already saw. So there are two forms of occupational exposure: whole body vibration, which is transmitted by mobile or fixed machines, where the operator is standing and seated or seated usually inside something like some sort of piece of equipment. And then hand-arm vibration is transmitted from things in the hand to the hands or arms. It's also called single point vibration as opposed to whole body vibration. So, but hand-arm vibration, because most of the time when you're talking about body vibration, it's coming in through your hands. All right. What three Michaels do you see in that picture? The Bulls 23 is who? Michael Jordan. The face and the hair, Michael Jackson. And that tattoo on the face, who's that? Mike Tyson. So there's three Michaels in that picture. It's pretty clever, I think. Potential injuries from vibration exposure: Raynaud syndrome, more modernly called hand-arm vibration syndrome, HAVS. Early stages are characterized by tingling or numbness in the fingers. Temporary tingling or numbness during or soon after use of a vibrating tool is not considered HAVS. Other symptoms include blanching, pain, and flushing. The symptoms usually appear suddenly and are precipitated by exposure to cold. With continuing exposure to vibration, the symptoms become more severe and the pathology may become irreversible. These are the stages of HAVS. The stage on the left, the condition of fingers, and work or social interference is on the right. So at 0, there's nothing going on, basically. OT, intermittent things, tingling. ON, intermittent numbness. TN, intermittent tingling and numbness, but all those. And an O1, blanching of the fingertip with or without tingling and or numbness. Now, in all those, there's no interference with anybody's activities. O2, blanching of one or more fingers beyond the tips, usually during winter. And this interference there is possible interference with non-work activities, none at work. O3, extensive blanching of fingers during summer and winter. Definite interference at work and home and with social activities, restrictions of hobbies. And it gets to be conditioned to the stage 4, extensive blanching of most fingers during summer and winter. Occupation, usually a change because of severity of signs and symptoms. So it gets that bad, you probably got to look for something different to do or have to. Whole body vibration can contribute fatigue, insomnia, stomach problems, headache, and shakiness shortly after or during exposure. These symptoms are similar to those that many people experience after a long car or boat trip. Bus and truck drivers found that occupational exposure could have contributed to a number of circulatory, intestinal, respiratory, muscular, and back disorders. Sources of whole body vibration in different industries, it varies. In agriculture, it's tractors; military, it's aircraft or boats; and construction, heavy equipment vehicles; in forestry, again, tractors; and mining, it's just vehicles, different vehicles; and transportation, of course, it's vehicles. And it's usually trucks and truck drivers and transportation. Some of the sources of hand-on vibration in manufacture are hand tools and pneumatic tools. In construction, they use pneumatic tools, jackhammers. Forestry and lumber, chainsaws. Mining, rock drills. Rubber industry, pneumatic striping tools or stripping tools probably. And sheet metal stamping equipment. Factors that can influence HAVS are, there's 3, these aren't, don't read across, just read these up and down. The physical factors is the one on the left, the biodynamic factors in the middle, and individual factors on the right. So the physical factors reads acceleration of vibration, frequency of vibration, duration of exposure each workday, years of employment involving vibration exposure, state of tool maintenance, protective practices and equipment, including gloves, books, work and rest periods. The biodynamic factors are grip force, how hard the worker grasps the vibrating equipment, surface area, location, and mass of parts of the hand in contact with the source of vibration. So there's how tight you grip it and how much of your body's in touch with it. Hardness of the material being contacted by the handheld tool, for example, metal and grinding and chipping. Position of the hand and arm relative to the body, the texture of the handle, soft and compliant versus rigid material, and the medical history of injury to finger and hands, particularly frostbite. Now, the individual factors are operators control the tool, the machine work rate, skill and productivity, individual susceptibility to vibration, smoking and use of drugs isn't good, exposure to other physical and chemical agents, and disease or prior injury to fingers or hands. To measure hand-arm violation, a different accelerometer will be used for an impact ham, like a jackhammer or chipper tool, than for a non-impact, like a chainsaw grinder tool. OSHA does not have a standard concerning vibration exposure. Measuring whole body vibration, an accelerometer is mounted in a hard rubber disc, which is placed on the seat between the operator and the machinery. Reducing vibration exposure, engineering controls. Of course, elimination means physically remove the hazard. Changing the process, thus eliminating the hazard. For example, protecting steel to prevent rusting, or using stainless steel, you eliminate the need to sand or grind it. Substitution, replace the hazard, installing equipment that vibrates less. Engineering, isolate people from the hazard, properly maintain the equipment, remotely operate the equipment, install vibration absorbent pads between the machine and the concrete floor. So we had a piece of equipment, a picker at California that rotated, had a big drum on it, which was a pretty heavy drum, and it spun, and it had fingers like claws to tear apart scrap material so you could put it back into the system. And we had one that was very, very noisy. You could not stand beside it without and have a conversation. And most of the plant wasn't that bad. So what we did was we took the thing apart. We sent it out, had it balanced. We changed the bearings in it, and we bought these pads that go between the legs of the machine and the concrete floor that are damper pads, particularly for this. When we put that thing back together, you could stand right beside it and carry on a regular conversation and hardly made any noise at all. So there's your good old hierarchy of controls: elimination, substitution, engineering, administrative, and PPE. Vibration damping tools. Tools can be designed or mounted in ways that help reduce vibration. Most reputable manufacturers list the level a tool vibrates as it comes out of the box. Tools that vibrate less should be purchased if possible. Conventional gloves don't do anything to reduce vibration. Vibration absorbing gloves are made of a layer of viscoelastic material, and such gloves have limited effectiveness. They can help a little bit, but they're not going to completely get rid of the vibration. Reducing whole body vibration exposure. Limit time spent by workers on a vibrating surface. Mechanically isolate the vibrating source or surface. Properly maintain the equipment, and install vibration dampening seats. That's for whole body. That's when you're in something like a tractor or a piece of construction equipment. So that's it for now. And we're going to stop this. And as you can see, I've got to get going. This poor lady here has been waiting for me all this time, just sitting there patiently. So I've got to get going and see what she wants. That's it for this time.